Aside from the linear pattern and the circular pattern, there are several other useful patterning tools within SolidWorks. The first we'll look at is the curve-driven pattern. And this allows you to select a curve or an edge as a direction to create a pattern from. In this case, we'll choose the top curve. For features to pattern, we'll choose the square cutout. And then from there, you can change the spacing, add or subtract instances, and you can choose equal spacing. The equal spacing can be useful if you're trying to create a bolt pattern around a perimeter or something similar to that. You can also change the alignment method of the feature itself. You can choose tangent to curve. Now let's take a look at what happens if we change to the other spline. You'll notice that that initial spline was through the center of the feature, whereas this bottom spline is not. SolidWorks will automatically offset this spline to the center of this feature and create the pattern based on the new spline that it sees. So it's generally best to actually draw in the curve concentric to your feature. Just like the other patterns, you can also skip instances, pattern faces or bodies as well, and create a geometry pattern. The next patterning tool we'll look at is the sketch-driven pattern. This allows you to select a sketch with sketch points in it, and it'll place a feature at the sketch points. In this case, once again, we'll choose that cut extrude as the feature to pattern. And then in the selection box, I'm going to choose one of the points, and that'll populate that sketch of points. I'll go ahead and click OK. And you can see if I edit the sketch at all, move these points around, it'll automatically repopulate the pattern. The next pattern we have is a fill pattern. And that allows you to fill in a boundary or a face. In this case, we actually want to create a face using this rectangle that we have here. And we're just going to do that by going into curves, choosing split line, selecting the sketch, and the face. And we just want to make sure that projection is the type of split selected. Then we'll go ahead and create a fill pattern. The first thing we want to do is select the fill boundary. We'll choose that face. Then you want to choose the features to pattern. In this case, we'll choose that box. Then from there, you can choose the spacing between the features, and it'll automatically populate the pattern. You'll also notice that if there are already cutouts in the way, it'll automatically pattern around those. You also have the option of changing the layout of the pattern. As well as changing some of the options, such as the degree that they're staggered away from one another, the edge direction, and any margins you want to add. In this case, we can add a margin of 1/4 of an inch. And lastly, instead of using the feature, you can actually choose to create a seed cut. And there are several different shapes that you can choose from here. Just like the other patterns, fill pattern also allows you to skip instances if we wanted to go back in and decided we didn't want some of these center cutouts. We can go ahead and take those out with the instances to skip. And the last patterning tool here is the table-driven pattern. And the table-driven pattern functions in the same way as the sketch-driven pattern. In this case, you can choose features, faces, or bodies to copy. You can also choose a coordinate system to reference off of. And then you can either enter in coordinates that you want that feature to be placed in, or you can open up a text file with the coordinates already loaded in.